Hello. Gonna play some more Sudoku today. So yeah, I'm just going to get right back into it. I'm going to try to get a lot done today. First puzzle, Fillominorinori by MathPesto. Renban and ratio. Cells on a purple line contain a set of consecutive non-repeating numbers. Cells joined by a black dot have numbers in a 1 to 2 ratio. Philomino. Divide the grids into polyominoes so that no two polyominoes of the same size share an edge. Each cell contains a number equal to the size of this polyomino. Norinori. Shade some dominoes of cells, i.e. pairs of orthogonally connected cells, so that every Philomino region contains exactly two shaded cells. Shaded dominoes may not touch orthogonally, and notes a domino can cross the region border. Okay. So Philomino and Norinori. Okay. So the first thing I think about with this is that all the lines, all the numbers on a Renban line have to be different, so they cannot be part of the same Philomino. For example, if this were 1, 2, 3, 4, then none of these could be part of the same Philomino. They would all have to be different. Which means that we can draw a distinguishing line between all of them. They're on the same line. Okay. This is at most 3. This one is at most 3 as well. This one's at most 2. Wait a minute. Does this mean that there cannot be any region of size 1? There can't be any 1 Philomenos, because of the Norinori rule. So that every Philomeno region contains exactly 2 shaded cells. So if you had a region of size 1, how are you going to fit 2 shaded cells in there? Okay. Oops. Which means this is a 2, that's a 3. 2 has to go there. They're both shaded. 3 goes here. Could go here or here, but since this one has to get out, it has to be a 3. 2, 3, this has to be 4, 5. This one has to be more than 2, so it has to be 4, 5 as well. 4, 5, 4, 5. There's a distinguishing line there. 1, 2, 3. This cannot go back over here. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. One of them is going to take one more cell. And shaded dominoes may not touch each other orthogonally. So these are unshaded. These two have to be shaded. These are all unshaded. These two could be shaded. One of these has to be a 6. Oh, I can also just draw a distinguishing line there. Four, 3, 2. 6, 7. This could be as high as 7. 2x has to go here. Auto parts. If this isn't shaded, the only way that could be possible is if this is a 5 region, and both of these are shaded. But this one has to go, this shaded cell would have to go to another cell to make up its domino, but in doing so would join up with this one, and therefore you would have two dominoes touching each other, which breaks Norinori. So this one has to be shaded. And whatever the next shaded cell in this one is, whether it's this one or if it's 5 it's that one, it will fulfill the domino here, either there or there, which means all the cells touching that have to be green, which means this one has to be the 5. And these two have to be shaded. This one has to come out, this one has to go up, unshaded. This is a 4. This one has to be at least a 4. The reason why is because it's coming out this way. However, if it's just these two, it can't get two shaded cells in there. These 3 can't have two shaded cells in there. So it has to be at least 4, and it can't be 4 or 5. So it has to be 6. 3, 4, 5, 6, 7. 6 or 7. This, wait. This could, it doesn't say anything about Fillomino's not being more than 9, so I can't assume that this can't be a 10, for example. 10 and 5 over here. Although this can't be a 5, because it would have to go down and touch a 5 here. So if this is a 6, this is a 7. If this is a 7, this is a 6 or 8. Has to come out here. This over here could be 4, 14, 3, 16, or 12. One is a 5. 3, 4. Either of these can be 2, so this is 5, 6, 7. This one has to come out, blocks that one in. This one has to come out. This one cannot go here. This one has to do that, this one has to do that. This one's at least a 3 now. At most a 7. Same for this. 3, 4, 6, or 7. I'll write that in. Also, these are unshaded. Because it's touching the shaded domino. One or two more here. This goes to one of these two, which means this is unshaded. What is next? This one over here has to be a 2. Because, again, there are no 1 Fillaminos in this grid. This one has to come out, and it can't touch any of these two. Otherwise, the number will repeat on the red band line. So that's 2 and 2. Both of them are shaded. All of these are unshaded. At least the 3. Three, 4, 5, 6. One of these has to be a 5 or a 6. Not necessarily. I can draw these lines. Can this really be a 7 with a 14 here? Yeah, it's semi-possible. This can't go here. Reason being is that this won't have to go here, and somehow 3, 4, 6, and 7. No, it can actually. Never mind, because you have 3, 4, obviously. Or 6, 7. Can this be a 5? If this were a 5, 1, 2, 3, 4, 5. This one have to be at least a 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, I can't do that. So maybe it can be. Three, 6, 5. Yeah, that works. 5 could even go here with a 10. Ooh. Or even 5, 7, 14. Inertia. A number equals the size of this polynomial. Yeah, it says nothing about digits. Maybe it has something to do with shaded cells. How do I fit 2 in there and 2 in there? Quite easily. If any of these are a 3, the rest would have to be shaded. No, I'm not getting this. I'm missing something. Oh, this one can't go here. This is a 2. This one has to be at least a 3. 1, 2. Could go here, could go there. These are all 3, 4, or 5. These are all unshaded. If this were a 3, it couldn't go there. It had to be a 4. Then go here, so this always goes here. Could be 3. Could be a 4. No. This one has to go here, has to go here now. This one has to go over there. This one cannot go here. So this is 3 or 4. And these two have to be the shaded cells. The Nori. I wonder why it's called that. Because I know like Nori in British slang or British vernacular just means to repeat oneself. 3, 4, 5, 3, 4, 5. One of these is a 5. So this is 3, 4, 5, 6. This one isn't a 5. This one can't be a 3 because it needs one more shaded cell in here. This is a 3 or 4. This goes here. Has to be 3 or 4. If it goes here, actually no, if this goes here, it has to be a 4. Because this would be 3. And if it goes here, then it has to be a 4. So this is always a 4. So this is either a 4 or 3 or 5. This square 3 could not go here, so it has to go over here. So let's do that. Could still be a 5 over here. Two are different. I think it's a 6. Can't prove that though. Not yet, at least. If this is a 4, that makes that a 3. And so this 4 has to go out here, and then there's two 4s touching, which cannot be the case. So this is a 5. Three goes here, 4 goes here, 5 goes here. This one, 1, 2, 3, 4, 5. These two would have to be shaded if it went there. Otherwise, 1, 2, 3, 4. 5 or 5. Whatever's the fifth one has to be shaded in that case. Intriguing. Three makes those two shaded. 4 less constrained. If this were a 3 though, then this one could not join up to here. Because those two would have to be shaded, this one would have to get out, and it would touch those two. In fact, if this is shaded, and it goes here, then all of those would have to be green. This would have to be a 4, and those two would have to be shaded. Does that break? Don't know. It is pretty forcing. Oh wait, yes it does break. Yes, it does. Okay, this is a little bit complicated. It's because of this over here. If this were a 5, if this 5 were shaded over here, it would have to come out here. This one would have to extend to be a 4. And because this is a 4, this would have to be 3, this would have to be 4. Well, it doesn't necessarily break, it just means that this one can't be a 5. Because then you'd have a 4 here and a 4 here on the same rim band line. So those aren't 5, this is a 5. There could be one more 5 over here or here, and that one is shaded. Whatever this is has to come over here. So either it's a 3, or it's part of the 4. And it ends there, in fact. This is a 5. This Fillomino's done. These two have to be shaded. These two are shaded. This is shaded. Unshaded, shaded, unshaded. This one has to be a 4 now. In order to get S2 shaded digits. Makes this a 3, makes that a 4. Three or 6, it goes here. Can't be a 3 because it needs one more shaded cell, so it has to be a 6. This one can't be a 4. This be at least 3, has to come up here therefore. This is a 6. 1, 2, 3, 4, 5. One of these is the last of that. This is unshaded. So this is shaded. These are unshaded. This one can't be 3, has to be a 6. Has to come to there. Now this one can't be a 6. 2, 3, 4. This one has to be a 5 or a 7, which means it comes up here, which means this does go here. This 6th region is done. Makes this a 7. These are no longer 7. This is 5 or 7. This 6 completes in one of these two. This is 3 or 12. This is 3 or 5, can't be a 6, because it's touching a 6. Can't be a 3 either, because this is unshaded. So this has to be a 5. None of these are 5 anymore. Comes up here. This one has to come out here. And I broke it. Oh, that's why, because this one doesn't have to go up there. Okay. It's true that this is a 6. However, it doesn't have to go up here. It could come down here. But you know what? This one has to come up here. This one has to go there. It can't join to over there, so it has to go there, which pans this one in. So this is either a 3 or a 6. Because this is unshaded, that means this one has to be a 6. This comes out to complete itself. This can't be 3 anymore. These can't be 6 anymore, because it needs another shaded cell. Can't go there. This is a done region. Oops. This is 4 or 5. This one has to come up, at least one. This one is 3, 4, 5, or 6. Could join to this. Again, this is unshaded, so this one cannot be a 3, has to be a 6. This one can go here now. This is 3, 4, 5, or 6. Can't be 5. Which means it can't join to this one. Also, this one has to be a 7. The 7 goes up here, which means this have to go up here. This one has to be shaded. These two have to be unshaded. This is a 7. Those are no longer 7. Three, 4, 6 has to come to at least here. This 7 goes here. Again, this is 3 or 12. So 7 can't join there. Has to go here. This one goes there. 1, 2, 3, 4, 5. At least there. 1, 2, 3, 4, 5, 6, 7. This 7 is complete. 1, 2, 3, 4, 5, 5 or 6. 1, 2, 3, 4, 5, 6. This one is also a 5 or a 6. Because either this is a 6 and it goes here, or this is a 6 and it goes here. In fact, this is just a 6. This is either 10, 3, or 12. I find it very hard to believe that there could be 12s or 10s in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does that fit? Because how many more cells do we need? This one is 3, 4, 5, which is 12. Plus, say, another 3 is 15. Plus another 2 is 17. So 17 plus 12 is, actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That'd be 17 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it does fit. This one can't be a 6. If it was, it would have to go here. But then this one would have to be a 5 and have to get out somehow, which it can't do. This is 3 or 4. 4, 3. This would be 4. Is redone. If this were a 4, 1, 2, 3, 4. Yet again, this would have to be a 5 and get out somehow, but it's pinned in. So this is a 3. This is shaded. This is a 4. This is shaded. This is unshaded, otherwise these two would connect. But there's only dominoes, not triominoes. Oops. This is no longer a 3 or a 4, this is a 5, this is a 3. These are shaded, this is unshaded, so is this. 5 has to come to at least here. This one is shaded, and it has to have one more shaded cell. That one has to be shaded. These are all unshaded. It either grabs this last cell there or there, which means we can delineate these. This one's at least a 4. We can delineate that. This one's not a 4 or a 6, it's 3 or 5. If it were 3, it would go here. 3, 4, 5, 6, and this one would be broken. So this has to be a 5. And that one's complete. This is also complete. What is this? Has to be at least a 5. But it can't be because it's touching this. So it's either 6, 7, 8, x, let's just say. Because it could connect to this, or it could go over here. Actually, no, it has to connect to this, in fact. Otherwise, it would pen this in. So that's a 7. 1, 2, 3, 4, 5, 6. One more over here. I mean, this one has to be it. Oops. 2 of these. This is 1, this is 2. Because they can't both be there. We can unshade that, shade that, shade that, unshade all these. This could still be 3. Oops. Or it could be 12. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, no, it can't be 12. Because how are we going to fit 2 more in the other one? This one can't be a 2. Because this is 14 spaces left. 6, 9, 11, 12, 13, 14. So it has to be a size of 2 afterwards. Somehow. Which means everything else would be part of the 12. So it'd have to be left there, but it can't. So this one is a 3. These two are shaded, unshaded. This one has to be shaded to complete this region. Can this be a 10 or 12? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It can't be 12. It can't be 10 either because there's only 11 left. So it has to be a 3. This has to be a 6. This has to be a 5. This one has to be shaded because if these two were shaded, then it'd be trialman over here. Could be this one, could be that one. If it were this one, then that would be shaded, which works. This one is a 3 over here, has to complete. 1, 2, 3, 4, 5, 6, 7, 8. There could only be 2 more, so it has to be 8 over here. Now let's complete the shading. One of these two is shaded. If this is shaded, that's shaded. That's shaded. And this is broken. Yeah. If this goes here, this one has to go here in the shading departments. All of these have to be unshaded, so this is shaded. And neither of these can be shaded now, so this one has to be shaded alone. So that's shaded. These two are unshaded. This is shaded. These 3 are unshaded. This one has complete shading. And there we go. Shading complete. Nice. Fun little puzzle. Fun little snack. Time for the next one. This one's a 5-star puzzle again, so let's hope this one doesn't take 2 hours. Confluence by MathPesto. Each row and each column of 3x3 boxes consists of 3 Sudoku boxes and 2 Fillomino boxes. Sudoku boxes. Each Sudoku box contains the digits 1 through 9 once each. Among the Sudoku boxes, digits cannot repeat in the grid's row nor columns. Philomeno boxes. Divide the cells in these boxes into polyominoes so that no two polyominoes of the same size share an edge. Each cell in a philomeno box contains a number equal to the size of its polyomino. Note, philomeno cells may not contain numbers greater than 9. Okay, so this one has that rule. Also, a polyomino may cross a box boundary if both boxes are philomeno boxes. Okay. Region sum lines. Each line is in at least 2 regions, and numbers have the same sum for each region the line is in. Okay. An entire Sudoku box and an individual polyomino are both considered a region. Note, if a line passes through a region multiple times, each individual segment sums separately. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 25 boxes. 9 of them are the Sudoku boxes. Yeah, 3 Sudoku boxes and 2 Philomeno boxes. Okay. And the rule set here is basically just finding which ones are the Sudoku, which ones are the Philomeno. And what's it called? Region sum lines. Okay, we know the Philomeno rules. There are Philomenoes of size n that take up that many spaces. Sudoku rules are just the normal Sudoku rules, 1 to 9 in each row and column in the Sudoku boxes. Region sum, say for example this is a 6, then this could be a 1, 5 or a 2, 4. Or if it was a Philomeno box, it could be 3, 3. Also say this was a 4 and a 6, adding to 10. Then these would also have to add up to 10, so it could be 1, 2, and 7. Let's get into it. The first thing I saw was this line over here. This is at least a 10 if it was a Sudoku box. However, because the Philomenoes can't be greater than 9, and Sudoku doesn't have any digits greater than 9, this one has to be a Philomeno box. I think I will do Philomeno boxes as green. Maybe I'll change that later. So we have one Philomeno box in this column and row. These two have to be the same number, so this is also a Philomeno box, which means these are Sudoku boxes. This one's also the same number as this, but it could be Sudoku. Because this is Philomeno, and the Sudoku digit doesn't see Philomeno digits. These two are the same number, which is the same number as this one, which means this one cannot be a Sudoku box. Unless two Sudoku digits see each other. That's Philomeno. Wait a minute. Huh? Ah, this is a different kind of region sum line than I'm used to. Each line is in at least 2 regions, and numbers have the same sum for each region the line is in. So it doesn't matter if it goes back into it or not. For each region that the line is in, it counts towards the sum. So these two equals these. This one still has to be a Philomino though, because this sees those. Or this one has to be less than 10. What's the least this can be? 1, 2, 1, 2, which is 6. These two can't both be Sudoku. One of them is Philomino. This one has to be Philomino because there's 1, 2, 3, 4, 5 digits in here, which if it was Sudoku would add to at least 15, which is not a Philomino or a Sudoku digit in this grid. So what's the least this can be? 1, 2, 1, 2, 1, 7. What next? If this is Philomino, lowest this can be is 4. Otherwise this is 6, 7, 8, or 9. Same for this one. One or both of these are Philomino, which you can tell because these. Four, five, 6, 7. Yes, no. Yes. If this were a Sudoku box, then the least these can add up to is the trigonal number for 7 digits, 1 plus 2 all the way to 7, which is 28. This cannot be 28. The max this can be is if this were a Philomino box. 3 nines would make this a 27, which is 1 less than 28, which means that this one has to be a Philomino box, and the rest are Sudoku boxes. What's the mass this can be? 24. The minimum this can be 3, 6, 9, 10. 2, 2, 2, 2, 1, 1. No. Who knows? If I find out that this wait a minute, can this not? If this were Sudoku, these would have to add up to 9. The individual phenomena in here. How does that work? You could just have 2 3s and 3 1s. Have 2 2 1 4. Yeah, it works in a bunch of ways. I am corpsing. Wait a minute. No, I still don't have it. This one is at least a 10. Not really interesting. This one is at least a 3. And where does that 3 go? If it took one of these, that would have to be a 9. Right? Because, say we had 3 like this. 2, 2, 1, 1, 4, 5, 6, 9, yeah. If one here, though, and didn't take either of those, which it would have to if it's anything more than 3. If this were a 3, 1, 2, 3, 4, 5, 6, head up to 18. Since that would be a 9, those be a 9. That'd also be a 9. That's very forcing. So why can't it go here then? If this were anything more, say it was a 4, it couldn't go here. Because then you'd have this, or at minimum, a 2, 2, 1, 1, 1, 2, 1, 2, which is 6. 6 plus 4 is 10, which is not a valid Sudoku digit. So 4 would have to go here. This would be a 3, 4, or 5. Let's see how it doesn't work. This is at least 21. That would have to be Philomeno. These would all have to be 9. This one would possibly be a 9. Why can't this be Philomeno? What if these are all Sudoku? These two are the same, these two are the same. I mean, they're the same regardless. This is at least a 6. These are all at most 3. I can put that on there. anywhere of 4. No, this one can be a 4. This could also be a 4. That can't be. That can't be. But this one can be. Because 1, 1, 1, 2. Why is this not a Fillomino? This for a Fillomino. One of these would also have to be a Fillomino. And all of this would be blue. Oh, that would be Sudoku. I'm not seeing why that's breaking. This is probably not. So maybe it is this not being. If this was Sudoku. Speed 3. 1, 2, 9, 9 and 9. Maybe that's why. If this were 3. No, that works. I was gonna say these would have to be 1, 2, 1, 2. Then what would that be? Well, it could be a 2. With those being 1 and those being 2. And if this were a 3, basically the same. Though it would have to go over here. Because if one over here, this would be 1, 2, 2, 1. These would be a 2, making those both a 1. So either it's a 3 which goes here, or it goes over here somewhere. Could it really be a 7? This has to be a 1. These would have to be 1 and 2. Is that a 1? Those are 2. That a 1. This be a 3. Yeah, that works. This would go out here. This would be the other thing and 7. Mm-hmm. Mm-hmm. Ooh, I am stuck. Ba-da-ba-doo, ba-da-ba-doo. I just really need this to be a Sudoku box. How can I prove this is a Sudoku box? What over here cannot be a Sudoku box? I don't really see it. Wait a minute. What happens if one of these two is a Fillomino box? If that happens, one of these two is a Fillomino box. In fact, let's just say, what if this one's a Fillomino box? One of these has to be Fillomino. Otherwise, again, repeating Sudoku digits. So this is Sudoku, which means this is 3, this is 9, this is 1, 2, these two are 9s. Sorry, these two are 9s. Because one of these has to be a Fillomino. No, not quite. Okay, that's how. If this were a Fillomino, that would have to be a 9, making that also a 9. And yet again, that breaks. But this would have to. This one has to be a Fillomino. And it can escape through here instead of taking that one. Okay, not quite. Wait a minute. Phenomenal cells may contain numbers greater than 9. Did I really just misread that? Yep, I did. I thought it said may not, but it's may. Oh, time to do the logic, redo logic. Because now, this could be a polyomino cell. A polyomino box. This could be Sudoku. If a line passed through a region multiple times, each individual segment sums separately. I did read that correctly. Well, I just had decisive moments. I literally switched these two rules. Phenomenal cells can be greater than 9. They can be a 10 or more. And if a line passes through a region multiple times, each individual segment sums separately. This means that this has to be a Fillomino, because these two sum separately. Well, we're basically doing a different puzzle from my understanding now. But this one is also the same. This also has to be a Fillomino, which means these are Sudoku boxes. This is at least a 10, which means that it has to escape somewhere over here or here, which makes the second Philomena, which means these two are Sudoku boxes. This one cannot be Sudoku, it has to be Philomena. These two are the same. This one, oh, this one has to be Philomena as well, because again, this is individual segments summing to at least 10. This is Sudoku. This is at least a 10. This one, yet again, if it was 1 through 8, we did this logic before, it would be 28s. This one would be at max 27, cannot be the case. This is Philomeno, which means these are all Sudoku. This is 270 or 9, can't be anything more, because it can't escape. In fact, this can't be a 9, because this line over here, and this line over here. It can't be an 8 either, because if you were to miss out one cell, say it was that one, that would add up to 9, but then this would add up to 16. So it's at most 7, which means this, it can't be 6. Wait, what? This has to be at least an 8. Uh, right. Okay. This one can be more than 9. It could be 10, 10, 10. Okay. If this one of these has to be a Philomeno. This is true. Because if it wasn't, 28, 24. This is the minimum, the maximum cannot work. Which means the rest in this column are Sudoku. This one, 1, 2, 3, 4, 5, adds up to at least 15. Which means this one, because it has to divide twice into here, it's at least 8. 8, 9, x. Can be more. Now, if this were Sudoku, then this could not be 9 and could not be 8 because it has to only miss out one of them, which should account for the 8, 1, making that a 9. But then the rest are both 16, which is impossible. So this has to be Fillomino. The rest in this row and column are Sudoku. How does this get out? It can't go through here. It can't go through here because, well, it could. Might be able to if it goes here. The point is it has to go through here. Or there, but it has to go to the cell. If it doesn't escape through the cell into that box, so if that wasn't taken, it can't go through here because these would be the same. Also, we can delineate this. It would have to escape through here. Can't take that one because of Sudoku over here. Sudoku digit. Have to go here. Have to go down here. No, it could. No, it can't. That'd be a 1, this one cannot be a 1. Okay, so it has to take this one. But it still could escape through here, though. If it were more than 8, then it couldn't take either of these. It would have to go up here. 2, 3, 4. Yeah, that works. These ones are at most 8. So are these at most 8? These could be anything, though. These are all the same. These two are the same. Yes. And it's that digit right there. Okay, so I should get rid of that because this could go there. Never mind. And it could be as small as 2. Small as 2 is big as a 9. I am quite stuck. Does one of these have to be a Philomino? If it's not, 1, 2, 3, 4, 5. 15 plus 1 is 16. This could be 7, 9. Or 8, 9. It's not necessarily. Although, yeah, no, it could still be. If this does not take either of these, it would have to be an 8. That works. Yes, it does. That'd be an 8. That'd be a 9. Use of 10. At most like 27. No, it can't be 27. If this were a 10, where could it go? You can't take either of these. 7, 8. Could be 910. We take one, not both of these. I would love for this one to be Philomeno. Fast Philomeno. Those are Philomeno. Does that break? This is at least 28. If these are difference, then I would have to go over here. But if it's the same, say it's 30 with 3 tens, it's a lot less restrictive. Hmm. Is there something I could do with Sudoku? I just really want these to be Sudoku. If that were Sudoku. Philomeno's over here. Over there. The rest would be Sudoku. I am not understanding this. Sorry for the dog in the background. These two are different digits. Whether that be Sudoku or Philomeno. I mean, no, these two are different. At this point, I'm just desperate. Just wait a minute. An entire Sudoku box and an individual polyomino are both considered a region. Is that saying an individual polyomino box? Or just an individual polyomino? Oh, that's confusing wording. It's a Fillomino box. An entire Sudoku box and an individual polynomial are both considered a region. Does that mean this has to be one thing that's at least 28? That'd be good. But these have to add up to 28. That's what it's saying, because you could have like a 10 and 8, that's what it's saying. Sorry, a 10, 12, and a 6, for example. Or a 14 and a 15. No. Each individual polyomino is a region. That means that these have to have the same thing, which could be a 1. Yeah, so this is 28. It has to be. These are all 28 or more. Because these has 27, has to taste at least one more, so it has to go up here. And both of these are Sudoku boxes now. This is at least a 6. I hope I have that right. What can't be 28 now? D, B, let's say. These can't be 28. This can't be either. So now they can that. So 27 over here. 28. Still can. Go over here. Let's be 28. No. 98765. 35. The max could be 17. If this were Sudoku box, what happens? This is 7-9 or 8-9. One, two, three, four, 5, 6, 7. 28 plus 6. Is 34. 17, 17. It would have to be the max. Where does 17 go? One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17. And 28 can't escape. In fact, does this have to be 28? Or at least 28. How does it not take this? No, it has to. This absolutely has to take this. Otherwise, it's leaving behind at least that much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, it has to take this. This has to be 28s. X. These two are Fillomino cages now. If this doesn't go here, then where can it be? Has to take these. Has to take all that. It would only be able to stay 27. So this has to go here then? I just proved that this couldn't be the case. Because of this. No. I forgot to divide this by 2. Okay. This has to be taken. If it's not, then where does this go? What cells can this take? And take all those. Nothing else. And that is 27. Therefore it has to at least go there. These are now Sudoku. And this is Fillomino. This can be 28. One of these has to be at least 28. But now, this, first of all, has to contain a 9. As well. This one being 1 or 2. This one. That shows that this could be a 9. Well, not really, because let's take that one. But I don't think this can be an 8 now. Reason being is that these have to add up to at least 34. 28 over here, and 6 over here. If we have 17 over here, minus 34, we have 17 left. So if it's just this, 8, if this were an 8, then this, it adds up to at most 16. Well, it adds up to 16, which is 1 less than what it has to be for the least amount of it. It has at least a 9. Which cannot connect to this one. 1, 2, 3, 4. Has to at least be this one. So this one has to be a 9. At least a 9. And at most a 17. This one can still be a 9. This one cannot be a 9. What happens if it's anything more than 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excel work. Excuse me. One, 2, 3, 4, 5, 6. Has to contain 1, 2, 3, and 4. Hmm. These are at least 28s. They can be at max 30. So this is 6, 7, 8, or 9. Can it be a 30? I don't see why it can't be. This is at least a 10. No, not necessarily. Could be 3. This is at most a 9. Same with this. This can't be 28s. Neither can this. Neither can that. So now where does it get 28 from? At least 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Where does it get 28 from? This can't be a 1. I am butchering this puzzle. This could be a 3. That does nothing for me. It can't be 1, it has to take at least 1 more. missing? That's definitely 27. Can't go to the ends. Can't go here. Because of that one. Can this be an 8? I think this has to be an 8 somehow. +20 + 6 is 34. Just for an 8. Does 9 have to go here? Yes, it does. Because this can't be a 9. In fact, it would have. Oh. Yeah, I think what I went wrong was just comprehending the rules in this puzzle. Alright, I'm gonna skip this one for now. I'm gonna go to the next one. Because I just cannot understand what's going on here. I think I have something wrong with the rules. I'm just not understanding them. Okay, next one. Boulder. Philomeno. Divide the grid into polyominoes so that no two polyominoes of the same size share an edge. Each cell contains a number equal to the size of its polyomino. Hey awake. Shade some cells so that shaded cells are not orthogonally adjacent. The remaining unshaded cells form one orthogonally connected area. A line of consecutive unshaded cells may not cross more than one polyomino region border. The number in a cell containing an arrow gives the number of shaded cells in the polyomino that the arrow is directly pointing to. Also, I believe this is Japanese, so it should be Heiawake. Okay. So shade some cells such that shaded cells are not orthogonally adjacent. For example, these two cannot both be shaded, otherwise it would break the rules. But these two could both be shaded, because they're not orthogonally adjacent. And all remaining unshaded cells form one orthogonally connected area. So, for example, these two could not be shaded. Otherwise, this would be unshaded, and it would not be able to connect with this one over here, which is also unshaded, or like any of these ones. So this would all be orthogonally adjacent, as long as if nothing else was shaded. Like, if that wasn't if this was shaded, unshaded, and it couldn't get to that, then that's not orthogonally adjacent or connected. The remaining unshaded cells form one orthogonally connected area, and a line of consecutive unshaded cells may not cross more than one polyomino region border. So if we had a, say for example, this was a polyomino, this was one, and that was one. 8, 3, 4, 6, 3, 4. This is not allowed because it crosses the region border here and crosses the region border here. However, if this was another polyomino, this can be the case because it's only straight lines that it's looking at. You can cross a border here and a border there as long as if it's not seeing each other. Finally, an arrow gives the number of shaded cells in the polyomino that the arrow is directly pointing to. I believe that these arrows, says if there are two arrows in one cell, they're counting the same. For example, if there were 2 in this direction, there would also be 2 in this direction. This would be a 2 instead of a 4. Okay. And it's not saying how many is in this direction. It's saying how many is in the polyomino that it's pointing at. So if you had a polyomino here, size 4, and you had these two were shaded, then this would be a 2. Okay, let's get into it. I am not sure where to start with this puzzle. Also, guys, there's a lot of Philomena puzzles in this batch. What does this mean? Wait a minute. These arrows looking directly at each other. How can that be the case? Because say you had any region. For any region, the max amounts of for any Fillomino, the max amount of shaded cells you can have in it is half that region. Because you have one for this, one for that, one for that, maximally. So if you had a clue that was 3, if this were 3, that means that the Fillomino it's looking at has to be at least 6. But then what happens if 2 are looking at each other? Doesn't that mean that it has to be 1? If this were anything more than 1, this would be a 2, making this at least a 4. But because this is a 4, that means this one has to be at least 8. It's an infinite recursion, which cannot be the case. These two have to be 1. Which means that these are both shaded. This one's at least a 2 now. It's also at least a 2. Also, this also means that arrows cannot go where they're pointing. The Fillomino in an arrow cannot go where it's pointing. Because if this were 3, and I went here, that means all 3 of them would have to be shaded. Also, this is unshaded. As well as this. And then they would all touch each other orthogonally, the shaded cells. This one has to get out. This has to do this. And we can delineate all of these. Okay, that's a good observation to make. This goes there. This has to go over here. This thing goes here. It cannot go over here, cannot point to itself. Has to come over here. This could be a 1. 1, 2, 3, 4, 5, 6. If this connected, well, first of all, it can't connect to that one. But if it connects it to this one, that'd be a 7. This would have to be more than that. It has to be at least 14. Which would make this at least 28. Impossible. There are at least 2 in here, so this has to extend a little bit. This is the same as this. So it's at least 2, so it has to extend this way. This one can't go here, because yet again, they're looking at each other. This has to be at least 2. Yeah, it's not possible. This one has to go over here then. This can still be a 1. As well as this can also still be a 1. This cannot go here for the same reason, because this, if it went here, it'd be looking at this, which would be looking at this, which would be looking at itself, which is an infinite recursion. Because this is at least a 2, this is at least a 4. Which means this one has to be at least a 1. Not interesting. This is at least a 2. But this is at least a 1. Which means this is at least a 1. Yeah, that's not just, no, this one cannot be 1. If this were 1, that'd be 1. It's not possible. So this is at least a 2, which means this is at least a 4. That goes there, cannot go there, goes there. No. Doesn't have to be a 4. It's 2x minus 1. Can be. Have I... This is at least a 4. This is 3, I mean. No, but it is still true for anything more than 1 over here, which is where I used that before. But this is at least a 2. That's true. Which means this is at least a 3, but it can't be anything more than a 3. Otherwise, it would look over here, which is looking back at itself. This is a 3. This is a 2. That's a 1. These 2 are shaded. These are all unshaded. This one has to go over here, shaded. This one's a 1. These are unshaded. This now has to go farther. Let's take at least 2 more cells. Also, this is a 3 now. This one has to be a 1. One of these has to be shaded because the Haywick rules. This one has to escape. This is also at least a 2. which means this is at least a 3. This one has to be a 1, making this shaded. These are both unshaded now. This has to escape. This one needs at least 5 more cells, or 4 more cells, to get 3 in here. Has to go to at least there. Cannot go over here, because then it'll be looking at itself. This one has to go over here, which means this one is a 3. It's over here. Cannot go there. This one has to be a 2. Making one of these. This one has to come over here, making that a 3, and shaded. This is quite a large region, oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 so far, wow. One is the 2, and has a shaded digit. This is the 3. Let's point at this one. Has to go here. It has to come out again. One of these is a 3. This is 1 or 2. This is at least a 5. Can it go here? I don't think so. 1, 2, 3, 4. No, it can. This one does not go there. Does not go there. Finishes right here. This one again needs to take another cell, making this a 3. I have a feeling it's going to keep on growing. This one has to be shaded. Otherwise, it would pass more than one region boundary for the Haywake. This one has to get out, connect to its friends. One of these is shaded. This one has to be at least a 5. I mean, this one finishes here. So let's get out. This at least a 3 is also to get out. This is at least a 2. This is at least a 5. No, 3, sorry. This is also at least a 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 so far, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, at least a 2, at least a 5. But it can be either. These could join up, is what I'm saying. This one has to connect to this. Just realized, because this is a 1. This one is staring at the same thing as this one is, so it has to be a 3. These could both be 1s. This cannot go there. What is this? This is at least a 3. Not really saying much. Well, it's because this is at least a 2. This one has to be at least a 4, because if it were just a 3, 1, 2, 3, then these both have to be shaded, which is impossible. This one's at least a 3, which means this is at least a 5. Also, this is less than this one. Could be 1 or more. This is shaded. That's shaded. This is shaded. That's shaded. This is some pair of shades over here. Which means that's shaded as well. Let's make it a 1. That one's less constrained. Also, this is more than 5. Honestly, it's probably this one. How much you want to bet all the 3s are looking at the same thing? There is a kind of wall over here that cannot complete. Make you come now. Everything will be forgiven. Wait, if this thing goes here, this will have to be a 3, which can work. If not, though, if this one goes here, this, because this is at least a 5, would have to be at least a 9. How does that escape? This goes here. This cannot go there, because that's a 3. It would have to be a 5 again. It would have to do that. But then this can't get out. So it's impossible. This thing has to go here. Which means this one has to be a 3, making those a 3. Has to go at least to there. This one has to be a 1 now. This is most likely just going to come up to this thing. This is a 3. Which means this is at least a 5. 2, 3. Still possible. This one is at least is the most of 2. This is probably called Boulder, because this is just going to be one huge rock in the grid. Everything will be forgiven. If you lay down your weapons to the ground. This goes here. That's like that. Also like that. Ah, that doesn't work. Yeah. If this ended here, these would have to be the 3. Which makes that one have to be 1 there, and this one cannot connect to his other friends. So yeah, this one has to at least go there. Also, this is now at least 6 now. Which means this goes here. These go to at least there. Lay down your weapons to the ground. What happens if this goes here? This would be at least a 5. This would be at least a 9. 1, 2, 3, 4, 5, 6, 7, 8. Not possible. Can't take that one. Can't take that one. Can't take that one. So that at least doesn't go there. Making a come now. Everything will be forgiven. Lay down your weapons to the ground. Is there anything I'm missing? Oh, this past this one has to be shaded. Unshaded. One of these is definitely shaded. One of these is definitely shaded. One of these is definitely shaded. If that's shaded. No, not necessarily. How does this get out? If this were shaded. If this were shaded, then that would have to be shaded. Otherwise it would pass more than one boundary. And then that would have to be shaded. Otherwise this would pass more than one boundary. Which means that it would get out this way. On the other hand, if this were shaded, that would be shaded. And then that would be shaded. Which means it would get out that way. Quite a predicament. Wait. Yeah, no, we can go over here. This one has to go here. It also has to go here. Oh, as it be passing more than one boundary. Same for this. This one has to go over here. So this is at least a 4. But it's because it has to get 2 more. It has to be at least 3 more than that, so it's at least a 7. Since this one is this more than 2, so it has to be at least 3. 3x. Now it needs 3 more, so 5 more than 4. This is at least a 9. Ooh. How does that work? One, 2, 3, 4, 5, 6, 7, 8, 9. Ah, that's how. This one has to go here. And it definitely cannot go here. Because if this were at least a 9, this would have to be at least a 17. Could that work if it didn't touch that one? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That could work. Darn. Very impossible, but it could work. It does have to. Wait, no. If this goes here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it would be stuck there. And that cannot be the case. Okay, that's pretty clever. If this were a 9, it would have to go here. And it would have to have at least 3 shaded cells, which would have to be like this. But now there's a wall in here that blocks off the unshaded cells from the rest of the grid, which is impossible. So it cannot go there. It has to go to at least here. Yeah. Which means these are the same. Can this be a 4? 1, 2, 3, 4. Make this one a 1. Can this one go here? No. Because this has 3 in it, this has 2 in it. Which means this one is shaded. These are unshaded. Also, this one cannot be shaded as it was created in a wall. One of these has to be shaded. So it needs 3 more, or at least 5 more. So this is at least an 8. Turn it all to ashes and blood. One of these has to be shaded. Let's see what I can do that with that. Turn it all to ashes and blood. At least I'm understanding this one. This one has to grow a little more. Because if it were just this, these would have to be shaded, which would block this one in, that unshaded cell in. So these to 6. If this were 2, then what? That'd be a 1 if that were 2. Ah, that's it. If this were a 1, if this were a 2, this would have to be a 1. This would go down to here, making this a 3, but that cannot be the case. This has to be a 1. What if this goes here? If this is a 3, this is at least a 5. If this is at least a 5, this one is at least a 9. It cannot join to any of the 3s. I want anything that's containing at least 3. The ones containing 3 of these. And it only has 3 things to go to then. For 5 things. For 5 shadeds. Which is impossible. So this does not go there. Either goes here or it goes here. Which is either goes there. There are pigeons on the roof. If 3 goes here, this is 1 or 2. This is 1, 2, or 3. This one is 1 or 2. To ashes and blood. Hmm. Da-da-da-da, play with nature. Do-do-do-do. This is probably all going to connect. Everything will be forgiven. Lay down your weapons to the ground. Hey, I am not even though. Wall. This is that, and that's that. How's it feel? If 3 goes there. This is 1 or 2, this is 1. Three. Nothing about 2x2 areas. I'm so close to finishing. This one is 1 or 2. That's for sure and certain. If this were a 2, it would have to be these two that are shaded. I just can't get anywhere, so this is a 1. Ooh, ee, ah, ooh, ee, ah. This is 3 or 4. Everything will be... Which means this one has to be shaded. If it's the 4, it takes 1 more, and it still has to have shaded one somewhere. Those are both green, orange shaded. Also, this definitely has to get out somehow. Because right now it can only have those 2 as shaded cells. And it can't even have those 2 as shaded cells. In fact, this one has to be unshaded. Because these have to get out somehow. If this is shaded, if this is the shaded cell, then both of these are unshaded. And in order to not go past one boundary, this has to be shaded as well, which would completely isolate this unshaded cell. So this is unshaded. One of these is shaded, which means this is unshaded, which means this one is shaded. I really want to shape this one. Because otherwise you have a bunch of 2x2s, but there's only about 2x2s in this rule set. Three or four, 3 or 4. This one's either 3, 4 or 9x. Oh, also, because it still needs at least 3, it still has to take at least 3 more cells over here. Which means this is at least 14. Everything will be forgiven. Wow. I wonder if it's saying that these two have to be connected, because the arrow's pointing to it. But I don't think that's true. I mean, it's probably going to be the case. More than likely, this is going to be these are both going to be 3s, and these are also going to connect to this. It's just a bunch of the same region in the grid. There was an old farmer who lived by the dock. Is there anything else I'm missing? No, this is the pattern over here. Checkerboard somewhere over here. How does it feel to cross a line that no one ever had to cross? If this went down here, this would be a 3. Doesn't really say much. This is a 2, this is a 3. If that's a 2, this is a 3. And then where's the 2 go? Can this be part of this? Or can it not be part of, what if it isn't part of that? If this is 2, that's a 3, that's a 1. This is impossible. If this goes there, this one has to be a 1. Shading this cell, making this unshaded. But then where does it get its 2 shaded cells from? Can't go over here. Has to either go there or there, which means 2 of them are connected to each other. It's impossible. So that's not a 2. If it went here, it has the same problem. No, not quite. No, it has a similar problem, actually. If that goes there, this is a 1, that's a 2. This one, it can't go there, has to go there. Has to have 2 shaded cells in it, which has to be that one. This one has to have 1 shaded cell in it, has to be this one. This one's blocked off, this unshaded cell is blocked off from the rest of the grid. So the only one left that it could go if it's a 2 is over here. Why can't these be 2? I've got sunshine on a cloudy day. Speaking very low today, aren't I? I just don't have that much energy. This is either 4 or 14. Or, 4 or x. Whatever this one is. I heard you say, what can make me feel this way, my girl? Talking about my girl, my girl. This is a 2. It can't be. This would have to be a 3, this would have to be a 2. This would have to have 2 shaded cells in here, this would have to have 1 shaded cell in there, and this would be blocked off. So it's not a 2. It's either a 1 or a 3. If this is a 3, it could have 1 or 2 shaded cells in there. If it's a 1, then the 3 has 1 shaded cell in it. One of these two is shaded. One of these two is shaded. If this is shaded, oh, yes! If this is shaded, suppose this is shaded, then make that unshaded, which makes this shaded by not crossing more than one boundary, makes that unshaded by Haywake. This can't cross more than one boundary, so this has to be shaded as well, and this is completely blocked in. So this has to be shaded. These are all unshaded, has to be shaded. Same for this, because of this. This one gets out through here somewhere. If this were shaded, that'd be shaded. It's completely blocked in. So this is unshaded, which makes this a shaded digit. Unshaded. One of these two is shaded. One of these two is shaded. This one's unshaded, which makes this shaded. Which means all these are unshaded. Which means this one is shaded. This almost has all of the things shaded. This one still has to escape over here somehow. If this were to turn to this, it would have all its shaded digits. This one has to escape. I heard you say, what can I make me feel this way? I have a very strong suspicion that there won't be any 2x2s of unshaded in this grid. Stands my suspicion for all these joining up, but now that this has 2 and that 1, I'm starting to suspect that these won't join up. One of these two is shaded. If it's this one, then that's also shaded. Possible. If this is shaded, that's shaded. Reason why is because if this is shaded, this has to come out here. This is unshaded, and then this has to be shaded. I've got the month of May. If this is unshaded, that's shaded. One of these two definitely does have to be shaded. Also, this has to take one more cell at least. It's at least a 7. What happens if this is a 4? This has to take at least 7 more cells, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it can probably work. But make this a 4 though. This didn't go there. 1, 2, 3, 4, 5, 6, 7. Yeah, I guess that could work. Do. Wait, if this is shaded, that makes that unshaded, which means this has to be shaded. It makes that unshaded, which means this has to be shaded. And these unshadeds are crowded into a corner. Can't pass more than one boundary. Can't pass more than one boundary. These have to be orthogonally connected to the rest of them, but it can't. So this one has to be shaded. These have to be unshaded, unshaded to get out, shaded, both unshaded. This one still has to get out. This one has to take at least one more cell. At least a couple more cells, in fact. 1, 2, can't go there. Has to at least join this one. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At least 15. Which means that this one is 3. So 1 or 2. This one's also 1 or 2. And it's the same as this. So they both point at that one. So this one has to be 2. Both shaded. Has to get out. That one's done. This has to be at least a 4. Ah, this is a 2, which means it cannot join to that. Which means this one joins to here, and that's that one done. Would eventually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Wow. It already has all 3 of these, so these are unshaded. What happens if I just turn this into A? Who knows? That goes to at least there. This one is at least a 4 as well. Cannot join to that one. That one goes to at least there. One of these is shaded. This one goes to at least there. That one goes to at least there. 8x, which makes this a 3. This one can join to that one. In fact, does it have to? How many more can you possibly have here? One, 2, 3. 1, 2, 3. 4, 5, 6. Surely not even more than 6. I don't think these could possibly go to the same thing. I don't think these can be difference. If they were, this has to be at least 8, this has to be at least 14. This would go there. This would go there. That'd be a 3. Which means this 3 would have to go here. Unless we completely cut off, it couldn't get 3 cells. which is impossible. Okay, which means this one does join that. Let's just call this B. This one has to be shaded. These are unshaded. I don't think this can go here. Because you have to fit 4 more somewhere here, which is impossible. Yeah, you can't fit 4 in here. 1, 2, 3 is the max. So that goes to at least here. These are most likely going to join up, but not necessarily. That goes there, and that goes there. This has to be a 2. No, this doesn't have to be a 2. Well, no, this one will have to go here to get at least 1 more cell. That have to go there. That would have to be a 2. This would be a 5. This would be a 4. Ah, that's broken. Because that would be shaded. So they do join up. This one does have to join its friends. Oh, so what is this? So it has to go there, and there is a 2x2 in the grid. I was not expecting that, to be honest. This one has to get, if it takes this one, at least 2 more over here. 1, 2. How does it not go here? It could do that. In which case, that would be the case. And what, this is a 1? No. Okay, if this doesn't take this cell, it has to do this. And all 3 of its shaded cells would be like that. But then, what's this? We have to go over here. It can't go over here, otherwise it would be pointing at itself. So this would have to be a 1, this would have to be the shaded cell, and this would be blocked in, which is impossible. So this one has to be B, which means this is a 3. It goes over there, this is a B. If that's 3, and that's the case, if that's 3, then that's the case. So this is always shaded. Either those 2 are shaded or those 2 are shaded. Either way, this is done. One of these is shaded. Can this be shaded? No, if this is shaded, then these 2 have to be shaded. Impossible. Which means this one has to be shaded. This one is not. This has to come down. These are 3 and B. This is a 6. If these two are shaded, if these two are B, then this cannot get to the other side of the board. So it has to be these two that are shaded. Which means that delineates B and 3. There we go. Good puzzle. Yeah. Still hard, but easier than this one, which I have yet to complete. I will do this one tomorrow. I'm just going to, in fact, just reset it for tomorrow. But yeah, I am going to go see a Minecraft movie with my nephews now. So I'm probably going to end the stream here. Thanks for coming back. Yeah, you left, but you didn't miss much. I didn't do anything else. Hopefully, no one will be throwing popcorn. Thanks. Alright, I'll see you tomorrow because I'm probably gonna be streaming. I'm gonna be streaming tomorrow as well. Bye bye.